Hi. So this is the lecture about the Negev Craterland Geopark in Israel, and I am Dr. Yaron Finzi. In this lecture, I'll be mentioning the concepts behind the global geoparks, concepts of geoethics, geoheritage that are relevant for the Negev Craterland. And I will talk about some local locations, details, issues, and show some images from the Negev Craterland. In many cases, if I don't have time to discuss the images, I will annotate them, as you can see here on the bottom left, saying, for example, that this is Machtesh Ramon Erosional Crater, and on the bottom right, either the periods or materials, in this case, Cretaceous, Jurassic, and Triassic rocks, you can see in the image. And to introduce these concepts and why they're important and why it's important to talk about geoparks, I will start the introduction by asking basically, who am I, or why is it important for me to discuss these concepts? I am a geologist. I study Earth, I study these fantastic locations in the Negev Craterland. They help me find new insights about natural hazards, earthquakes, risk and community resilience, the stability of cliffs, and the evolution or formation of the craters, and also topics of geosystem services, which are the benefits and impacts that nature has on mankind. I am a geologist at the Dead Sea and Arava Science Center in Israel, which is a research institute. And to explain its uniqueness or its special characteristic, I have to first tell you a little bit about Israel. You can see in the map the location of the big cities, Tel Aviv, Haifa, and Jerusalem, here in the green area, the vegetated area closer to the Mediterranean Sea, and the southern part of Israel, the Negev desert, is depicted here in brown and yellow colors because it is a desert. This is made more obvious when we consider the climate regions of Israel. So there's a transition, a steep transition from Mediterranean climate with 400 to 900 millimeters of rain near the coast to semi-arid, arid, and hyper-arid climates all across this several kilometers, tens of kilometers in the small country of Israel. And obviously the cities, the populations are mostly in the northern western part that has more subtle or wet climate. This can also be seen easily in this interesting map, which actually shows the radiance of artificial light. In other words, light pollution, light that is related to man-made structures and facilities and cities. And what you can see is that the approximately 14 million people within this area of Israel are mostly almost completely located in the northern half of the country. And the only place that isn't lit up, isn't covered by man-made features, cities and settlements, is the southern desert, Negev desert, which basically constitute the only open space, untouched natural environment, large environment in Israel, which is part of its importance. So this Dead Sea and Arava Science Center is what we call a rural research institute. It has 4 branches, 4 offices, all located in the less populated, more extreme condition desert of southern Israel. One office is near the Dead Sea, the other one, along the Arava Valley, near Eilat, and the 4th office, which is where I work, and we will talk about this area, Mitzpe Ramon, which is sitting on the transition line between arid and hyper-arid climates. So the research center is dedicated to promote science where universities are not, do not exist, do not work so much, devoted to promoting this science and research and to provide insights to schools, to communities, to authorities, and obviously to disseminate, to give these insights to everyone who needs and support the processes, nature management or community-related policy decisions. And this is part of the goal, the aims of the Dead Sea and Arava Science Center. Specifically, the branch, the office I head and I work as a geologist at is the Mitzpe Ramon, which is in the center of what we call the Negev Craterland. Why is it called the Negev Craterland? Because it is characterized by elongated ridges. You can see them here, elongated mountain ridges. And many of these, or several of these, on the top of the ridge have a crater, an erosional crater. What is this erosional crater? It's basically a hole dug along the ridge of the mountain. It's a valley within a ridge confined by cliffs formed by erosion, and which exposes old ancient rocks within the center of this ridge. So this is a cross-section across the largest erosional crater known, which is called Machtesh Ramon. The cross-section here shows us from north to south that the northern edge of the crater where Mitzpe Ramon is situated is at about 850 or 900 meters above sea level. The cliffs fall steeply to an altitude of 750 or 700 meters above sea level. And if you continue about 5-6 kilometers south, you reach the southern cliff, the southern edge of the crater, which rise up, and this is how the crater looks. It's a steep valley confined by cliffs. I'll show you a few images of how this actually looks in the field. This is Machtesh Ramon. Machtesh is the Hebrew name for an erosional crater. What you can see here, and in the very rare occasion of precipitation and cold weather, you get snow accumulating for just a couple of hours, typically on the very top of the cliffs, and obviously in the crater itself, where the temperature are higher and the elevation is lower, you don't get snow, so you can here use this image to see the edges of the crater very clearly. Another image and another atmospheric phenomena, you can see what happens to the moist air coming from the Mediterranean, the clouds when they gradually climb up the ridges. They reach the cliffs of the crater and they fall into the crater and dissipate. Evaporate. This is what we call a cloud fall. It's a beautiful phenomena. You can see it every year, several times a year. Now, this is the town of Mitzpe Ramon, small town in which I live. I'm a member of the community, this community that is realizing its natural beauty, its responsibility to protect its natural environment and to celebrate the connection it has with this natural environment. It's a town of about 5,000 inhabitants. It was formed in the 1960s, basically as a worker town for people who worked in excavation of resources, sand and clays and other resources from the crater and from the area, and also people who worked in construction of the road system from central Israel to the south. In the past 30 years, there was a huge transition of mindset and of economic activity from resource industry and heavy industries to tourism. You can see that tourism includes hiking and guided tours and obviously driven tours, but also astronomical observation of night skies, which are beautiful in the desert. There's no clouds, there's no light pollution. And also at the bottom right, the opportunity, the possibility to observe natural phenomena which are rare, exciting, huge, fascinating, like flash floods. You can see all these in this environment. Now, I mentioned that I'm a researcher, part of the Dead Sea Arava Science Center, part of the local community. As a scientist, I'm a part of a global science community. I'm also a person. So where are my responsibility? Who do I how do I go about thinking about the priorities in this area and my responsibilities? So these are questions that are relevant for all geoparks, and they're basically discussed in the field of geoethics, which is describes the moral principles, responsibilities, duties of scientists, geologists, and other people of natural sciences that work and study these natural environments. And these help us scientists, and they guide us to sorry, they guide us to address all the different obligations and sometimes resolve the dilemmas between global responsibilities and local responsibilities, between the need to keep scientific integrity and sometimes the needs or economic needs of local or national levels. And there are associations like the International Association for Promoting Geoethics and the Union for Conservation of Nature that deal with these. And the concepts that led to the development of geoparks and to discuss these thoroughly, they were developed historically by many philosophers and conservationists. I've noted too that sort of caught my eye, the Dutch philosopher of the 17th century, Baruch Spinoza, who basically said, was quoted to say God or nature, meaning that there is no duplicity. Everything is God, nature is part of God. This is an expansion of basically pantheism, saying that God is not just everywhere, he's also in everything. Everything is part of him. And that kind of thinking was later interpreted and developed into ecological or conservation values represented by the Norwegian philosopher and conservationist Arne Næss of the 20th century, who developed ideas of deep ecology, in which there's a very important intrinsic value of nature. So nature by itself has a value, not just as a service or resource for human beings. Basically, perhaps paraphrasing Spinoza, it's sacred by itself, not just as something useful for us. And this kind of thinking is also called ecocentrism as opposed to anthropocentrism. Basically, it pushes us not just to think of everything from the perspective of benefits to us, to human being, anthropocentric. It broadens our thinking beyond just thinking of everything living, like biocentric thinking, and it pushes towards eco and geocentric approaches. Basically, man is part of all living creatures and part of all ecosystems and nature. The other concept that's crucial for understanding the geoparks is the balance between a global need for sustainability or a global approach and a local activism. Sort of put it in a slang word of global and local. And basically what we need to understand, and is really done nicely in geoparks, is that in order to preserve global diversity and sustainability, we actually need to approach the local uniqueness and conserve it, identify it, conserve it, monitor it, the local aspects which are unique and special. They are a crucial part of global diversity. So the last concept that we need to understand when we come to discuss geoparks is that of geoheritage. And the definition as given by UNESCO and other international bodies is the geoheritage are sites and features, artifacts with significant scientific value, with educational, cultural, or aesthetic value. And these sites are used for research, teaching, recreation, and they're important. These sites, in essence, they are like the photo album or the open book, history book into nature. We can use them to read, to understand the evolution of planet Earth, the surface, the landscapes, the life, culture, and science, even science as an activity. So the field of geoheritage is dealt in conferences, and there's a journal, Geoheritage. And as an example of how important this insight, the geoheritage is for understanding Earth, I present here a plot, a graph of carbon dioxide in the atmosphere. It's a known plot related to climate change. It's the famous hockey stick, equivalent to temperature rise along time. And it's important to realize that while we measure temperature and carbon dioxide in the past 50 or 100 years, we rely on geoheritage. We rely on information from planet Earth to reconstruct all the knowledge we have about Earth in the past. And this knowledge, this insight comes from ice cores, tree rings, corals, caves. These are sites, artifacts that give us these insights. This is an example of geoheritage, allowing us to understand the history and the evolution of the atmosphere, of the planet, of the ecosystems. Now, the geoheritage, the main feature of geoheritage in the Negev craterland is obviously the erosional craters. This is what UNESCO characterized as an outstanding universal value. Okay, these are the craters. I showed a few figures before. This is the small craters near Dimona in the Negev. This is the big crater, or Yerucham crater, named after the city Yerucham. Arif crater. In Hebrew, the word erosional crater is a machtesh. Machtesh is the pestle. There's the mortar and pestle mentioned in the Bible. The bowl, pestle, is called machtesh in Hebrew, and because it looks like a crater, this is the term that is used in Israel. So what's so special about the erosional craters? Well, it has to do with the mechanism of how they are formed and implications of that. So it's important to understand that erosional craters are not impact craters like you see on the moon or in many places on planet Earth. And they're not volcanic craters or calderas. They are something completely different. I've put up some GIFs of mechanisms for creating the craters, volcanic, top right, impact crater, bottom right, and, well, a dog digging here. To emphasize that in an erosional crater, the process is slow, a long process over millions of years. It is related to tectonic processes. It records the regional tectonic processes and their effect on morphology. So basically, of these mechanisms, the erosional crater is pretty much, well, it's more like a dog digging for millions of years. But no, more seriously, I will show you the stages, the general stages of formation of the erosional craters in Israel, and their history. Their formation starts in the Triassic period by simply deposition of many, many sedimentary layers of sandstones. And this is in Pangaea before it broke up. And later, when the Tethys Ocean flooded this area, a deposition of oceanic sedimentary rocks, limestones, in the ocean. Much later, in Cretaceous time, about 80 to 70 million years ago, when Africa collided with Eurasia, you get, in this collision, you get buckling and folding and uplifting of mountains, and this is what happened to form the elongated ridges that I showed you before, that are characteristic of the Craterland area. About 30 million years ago, in response to a different tectonic event, uplifting of the entire northeastern Africa and Arabia area by a hotspot, the whole area was uplifted. The basins were filled even before, and when 30 million years ago the area was uplifted, it formed a huge system of rivers as big as the Nile, and these eroded the surface, flattened it, and formed what we call a regional truncation surface. And most importantly for us, they broke the cap of these ridges. The islands that had this limestone on the top were basically decapitated. So the erosion exposed the softer sandstone that is in the heart of these ridges. And about 10 to 5 million years ago, again, another tectonic phase, the opening of the Dead Sea Valley, Dead Sea Basin, the formation of Dead Sea Transform. What we got here locally is a shift in drainage, and suddenly rain and flow of water could erode and drain the softer sediments within these ridges and get them out of the structure through gaps towards the lower Dead Sea Valley. So it's 5 million years ago that the morphology, that the valley was formed, but the formation had to go through all these stages of about 240 million years in order to get here. And the result is that the digging of this hole, this valley, the excavation of the material exposed older and older layers of rocks. Okay, in the crater, you go from Cretaceous limestone on the rims, and if you cross it, you can cross it by foot. It's a half-a-day hike. You go through lower Cretaceous, Jurassic, Triassic rocks, and then back to the outer rim with upper Cretaceous limestones. So a lot of geologic record, a huge, vast, almost continuous record of indications of tectonic processes, of environments. They're all preserved and exposed and accessible in the Ramon crater in this case, but in all erosional craters, most erosional craters in Israel. Which brings us to the last term that is very important, geodiversity. Geodiversity is defined as the variety of earth materials, forms, landscapes, processes. These basically provide the foundation for the diversity, the biological diversity, diversity of habitats, ecosystems and landscapes, and even they contribute significantly to the diversity of cultural heritage. This is the foundation of the diversity we see in our life, in our everyday life and our historical heritage. A few images from the area of Machtesh Ramon of the Negev Craterland. You can see a rock art, which is ancient, drawing on these laminated rocks. This is an example of cultural usage of the material and the properties of the rocks. That is obviously geodiversity dependent. The ibex that survive and flourish along the cliffs. Without the cliffs, they wouldn't have shelter, which is very important for them. It's kind of a unique habitat tailored to their abilities. There are several endemic plants. I'll probably mention a few more in a second, related to the fact that it's an high altitude desert environment, and related to the various materials within the crater, different rocks, different landscapes evolve different soils and different growing environments. When we come to talk about geodiversity and think of the importance, I often like to remind us and remind students that we ourselves, our bodies, are a reflection of the geodiversity. Our composition of the body is, as you can see, mainly oxygen, carbon, hydrogen, and nitrogen, but it's a direct reflection of the composition of the Earth's crust. You can see here a diagram showing the Earth's crust compared to the human body. And the main differences between the Earth's crust composition and human composition is because the surface of the Earth is very unique. It's not the average composition of the crust, because it's covered 75% of the crust is covered by sedimentary rocks, which actually have a lot of carbon and hydrogen. In other words, we are made of the materials that we live on, that represent our environment. Our food, the whole food chain is based on the minerals, atoms, elements available around us. So in other words, we're recycling the same material, or as culturally, we can say that we are literally stardust. We are made of the same material as the Earth and the galaxy. To some students, this doesn't, they care less about the composition of their body and care more about the composition of their cell phone. So I mentioned that it too is made of resources, elements, rocks that are found in our environment. In fact, at least 3 of the compositions of the display and the electronic circuitry of the cell phone could be found, could be excavated, and some of them were excavated in Maktesh Ramon. The bauxite, for example, the sand and silicon, and also the arsenopyrite can be found in Maktesh Ramon. So there we are. You can hike around nature and see the elements, the compositions, the building blocks that build our body, our technology, everything that we know and have. Now, geodiversity encompasses values, a very wide, different values they represent. Obviously, there's the scientific value of being able to learn of them, of the ancient heritage and evolution of ecosystems and Earth and life from them. They represent educational and cultural value, including aesthetic, which is related to our well-being. We go out to nature to enjoy the view, to relax, to connect to our feelings, to get inspiration. So it's also a spiritual value, and obviously economic value as building blocks, building materials, for houses, for everything we have, resources. But it's important to remember that some of the geodiversity components, the geoheritage around us, nature has its intrinsic value. Even if we don't take advantage of it, even if we or a community or a society do not value a certain aspect of nature, it has value. Now, in the Negev Craterland, when we talk about geodiversity, and I mentioned this, it's as rich as it can get. In a short hike, and I mentioned this, across the crater, Maktesh Ramon, you can see a lot of different types of rocks, soils, resources, ecological niches. As I mentioned, the cliffs are of, for example, Upper Cretaceous. Volcanoes in it are from Lower Cretaceous, and they form different soils, different habitats. There's many, many, many examples, colorful examples. These are Jurassic rocks, clay-rich, and some of these were actually excavated for alumina and other materials. Just to maybe overwhelm you, but not too much to overwhelm too much. Some photos of different sites that represent important geodiversity. Some require some explanation, like this crack. There's sets of cracks within the hard limestones that circle and limit the crater. These cracks actually collect a lot of soil, organic material, and moisture, and they are actually tiny micro ecosystems. In these cracks, you can find plants that grow 5-10 times bigger than outside the cracks. So it's quite an amazing location supported by a geological feature. Another example of geological feature that can teach us a lot about natural processes and historical evolution of the landform are these igneous intrusions. This is a dike, crosses the layers here. The two images on the right represent ancient landscapes that were basically preserved, fossilized in a sense. This is a riverbed in sandstone, and these are the purple sediments here. The purple rock here are sediments or mud stone that accumulated within a karstic limestone cave, bell-shaped cave, and actually represents or indicates or tells the story of the climate change due to tectonic plate motion that this area experienced in the transition from Triassic to Jurassic, basically from desert to more tropical environments. And many more features. This is flint rock, flintstone, that is very twisted and curly, that represent the dynamic motion of layers, mud layers in the oceanic environment in which it was formed. Many, many more volcanic features, metamorphic features around the volcanic intrusions, and of course, plenty of fossils. These are tree fossils that are found from lower Jurassic period. And there are many, many fossils. Some of them are of significant importance. There were salamandra and frog fossils found in the crater that sort of represented the transition of these creatures on land, an important evolutionary stage. Now, all this diversity in geodiversity provides a foundation, a fertile land, if you want, for the formation of many unique, tiny, fragile ecosystems, and also for niches that provide agricultural potential or provided agricultural lands for societies that actually, you can see ancient cities that were built in this area, and terraces that in which soil was retained and water was controlled and diverted in order to form farmlands. This is a modern one, but it's built on an ancient system of terraces that constituted a huge array of farmland in this desert area. So the natural heritage, the geodiversity, enabled a huge diversity of human activity, and obviously ecosystems such as flood pools and springs, and the evolution of endemic plants like the Amygdalus ramon, the caper ramon, and the rhubarb, which are only located on small areas in this area due to very local conditions. So with all of these unique and beautiful and important geological and natural properties, why do we need to become a geopark? What does all this have to do with the global geopark network and with the concepts behind it? Which is a question that the local community has asked and have been asking for a while. And considering what we know today of the geoparks, the values behind the concept of geoparks, we as a community have adopted many of them and are working to establish the first Israeli geopark. So to introduce geoparks, I'll start by mentioning that since 2015, the Global Geopark Network was adopted by Unesco Global Geoparks, which aim to increase awareness to geoconservation and geoheritage. The network, you can see the map of member geoparks, consists of 169 geoparks in 44 countries. The network encourages collaboration in research, in conservation, in promotion of geotourism, education, and so on. The geoparks and the network coordinating the geopark work, they create a framework and various motivation and support for the communities to integrate research, monitoring, education, and geotourism in sustainable development of rural communities. So basically, they always balance the global guidance of sustainable development goals with the local needs and local uniqueness of the geoparks. As they say here in their under the logo, celebrating Earth heritage and sustaining local communities. So the way UNESCO defines a geopark is it's an area of international geological significance, which is managed with a holistic concept of protection, education, and sustainable development. It's interesting to understand that it's actually not all about geology. Okay? The 10 most discussed or topics of interest in these geoparks, they include natural resources and geological hazards, also global climate change, education, science, culture, women, sustainable development, local and indigenous knowledge, and geoconservation. So a very wide approach that emphasizes the connection of us as people to the natural environment in a local and global way. A few examples from France and China, and sort of emphasizing the cultural aspect and the tangible benefits that people get from geoparks and that geoparks represents. They include fostering geotourism and a local industry of produce and arts and crafts that is based on local traditions, and basically by increasing these, we help to give a common identity to a region of a geopark and pride and sense of place, and obviously support enhancement of environmental and scientific education and awareness to the topics that we mentioned, and of course the more involvement of residents and communities with geoconservation. These are all tangible benefits. You can see in this promotional movie that UNESCO made about geoparks, you can see obviously the geological features, but also you will see a lot of relation to geotourism, to ecosystems, and to diversity, biodiversity, And this is the most basic aspect, preserving geoheritage, conservation, and doing it by connecting people to nature. And the connection is often through the local traditions, the local lifestyle, the unique connection that certain communities already have to their natural environments, and obviously supporting them by industries and tourism and promoting traditional products. All this, of course, while keeping or maintaining all of the sustainable development goals that are defined globally. And the main tools are always geotourism, education, research, and conservation. So again, to go back to the Negev Craterland Geopark, our goals basically reflect those that we just saw defined for the global geopark, for the UNESCO Global Geoparks. The main goal is to conserve the unique geoheritage, and specifically we mean not only the geologic heritage of the craters, but the connection that the local society, local communities and ancestors in this land have always had with their environment. This is an extreme condition environment, extreme climate, and always rural, remote in our history, and people have always survived. People have always sought the desert for inspiration, for contemplation, connecting with God, connecting with yourself. And this geoheritage, shared human, historical, cultural, natural heritage is the unique thing we wish to conserve and celebrate. Obviously, we want to foster and strengthen the connection we have to nature and show it as an example for the entire country, to help people from cities come and experience this connection to nature and realize the place attachment, the pride that the residents have from living in a natural environment like this. Obviously, we also want to promote the resilience of the community by supporting or diversifying the tourism, the economic income of the area by different types of geotourism, sustainable tourism, and we want to enhance natural and scientific and environmental education and increase awareness to hazards, natural hazards and others, and also promote more and more research and science to help support science-based decisions and policy and nature management. And maybe the most important is that the Geopark, the Negev Craterland Geopark, is meant also to empower the local community, to give it more of a say, more of a part in the management of the natural environment and the interface with community. And we keep in mind that this, preserving the local uniqueness is actually a national and international goal of preserving diversity. So what are we doing? The Dead Sea Arava Science Center and others, we have many activities, and this is a very busy slide, but it's meant to show you that we have many educational programs for all levels of schools and adult education. We have many community events and field trips and courses about the natural environment and lectures. We consult the authorities and entities that work in this area, including, for example, in building exhibitions on the natural environment and protecting geosites, geoheritage. We also try to disseminate the insights and the knowledge to increase visibility of the geoheritage, whether it's with signage or online apps for explaining about the natural environment. We've developed a course for tour guides that they should know about the Geopark. We've even written a book about Erosional Crater and games. We also encourage and involve advocacy and involvement in policy making by the local community. And of course, we are a research institute, so we encourage and conduct research and monitoring of the environment and various different scientific aspects of their natural environment. As I said, community engagement and involvement is one of the important things, so I'd like to touch on that a little more. In recent years, there's been a lot of involvement and activity, and the local community has been more and more appreciative of the need of conservation, geoconservation, in this case, fossil preservation, awareness, and an awareness to geoheritage. This is a news item describing the 75 million year old fossil of a sea reptile that we found in the Negev Craterland. Community members found it. They came and pointed out that they're being deteriorated, and in a shared effort together with the Hebrew University, we excavated and saved the fossils, and we left whatever is safe in the field, so it can be appreciated by tourists and tour guides. We also conducted a couple of field trips to the field site to show the people and the tour guides and community members the fossils, and we took them to the National Archives to show them these fossils and other fossils that came from the Negev Craterland, and all these increased awareness of the geoheritage and the need for geoconservation, and also about the need of awareness of the local community. After all, it is typically the local community who is first aware of a problem on a local scale and can get the authorities involved and to find solutions. Another two examples of engagement and successful fights or campaigns to preserve geosites and sustainability. On the left here, it was a big campaign by community members in Ramon that basically managed to stop an initiative of the Ministry of Tourism and the local municipality. They wanted to build a big amphitheater in the middle of Machtesh Ramon, of the crater. And the local community members said that that is actually wrong, it's a bad idea, it actually contradicts the general understanding that the main geoheritage feature of the area is the crater itself, is the natural environment, and then putting an entertainment center such as an amphitheater doesn't serve not the local communities, not future generations, and this was a campaign, a successful campaign, and it was cancelled. The whole program was cancelled, and now they're thinking of alternatives and alternative locations for the amphitheater outside of the crater. On the right, there's a big international motorbike competition that is planned for the next few weeks, I think, in the Craterland and the desert and the Negev, and it is alert and aware citizens, community members that realized that there was not enough regulation and not enough sustainable conservation in the planning, and basically the organizers might have, if there was no interference, might have caused a lot of damage to the desert, to archaeological sites, to fossils, to tiny ecological niches. And this is an ongoing campaign which is hopefully the local community will manage to mitigate the damage from such events, and also increase the awareness of the need of geoconservation, ecotourism, and so on. The final example that I'll give is another very successful example a few years ago actually last year, across the Machtesh Ramon, the large erosional crater. The electric company of Israel built a huge line of electric towers and high electricity power lines. And this was right along the paths and roads that go into the crater. So all the tourists, all the people who come to enjoy nature are now driving along such electric lines. And the community got engaged and demonstrated and gained support of media and politicians, and eventually, after a long process, managed to get the government and authorities to commit to take them out, to take these electricity towers out and basically bury the high power lines in the ground. In this way, they will preserve the intangible value of natural landscapes, of open space, which is very important. Even the fact that local community members managed to convince an entire country and authorities that the view, the feeling, the emotion of being in untouched, pristine desert is an important value. It's as important as saving money and as important as committing and investing in extra work to bury the electric lines. And this was a very successful example of how social groups and local members of the community can have a big impact. These are mainly WhatsApp groups in Israel and Facebook groups, the Crater Protectors and Sustainable Desert Group, two very active groups that are protecting and are aware of every violation or danger, threat to geodiversity, geoheritage, and nature in the desert. There's a local NGO called Keshet that deals with social and environmental issues. And several local regional institutes, such as the Dead Sea and Arava Science Center, in which I am a geologist. So the point is that local activism, local awareness, local collaboration is sometimes very, very important to protect the uniqueness of an area, because sometimes national and international governments or international procedures, they're not aware enough of the local value, local priorities, local assets, heritage, uniqueness that is so important for local communities. It's part of our life, but it's also important to preserve the diversity on a global scale. So to sum up, some of the main concepts that were presented and discussed in the talk: geoheritage and eco or geocentrism, the very important concept that man is part of the kingdom of life and part of the ecosystem and part of nature and earth, and we cannot judge everything by the perspective of what is the benefit for me or my community. It's we should keep a broader perspective in conservation. To help us, there's concepts of geoethics. These are very, very relevant for any scientists, any geologists, but also for educators, that remind us that we are responsible not only for our project, not only for our funder or boss. We are responsible to the integrity of science and to its service to humanity, to the local community, and to the sustainability and global sustainability. And in that sense, the efforts to preserve the local uniqueness actually support and are crucial for keeping the global diversity. So in the geoparks, the local communities are empowered, their priorities are emphasized, their local connections with nature are celebrated, and this is what makes our basics for the global diversity of geoheritage and so on. These are the geoparks concepts. I think they are very, very important at this time where people are less and less part of nature as this superiority that we can fix or we can harm nature, and basically seeing us not as humans, not as part of nature. And the geoparks helps us reconnect and celebrate the local connections between communities and their environment. And they're very, very important, and that is why very suitable for places like the Negev Craterland and Mitzpe Ramon, and we definitely have adopted these and think they are appropriate. If you come and join us and see the Negev Craterland, I think you will see that it is like a huge classroom, an environment dominated by geology, by untouched landscapes, and we can learn a lot about geoethical dilemmas, geoconservation, the role of communities in nature management, and so on. So thank you very much.